Alright, here's 8.2. And we are just going to get really specific with confidence intervals and look at proportions, which should feel somewhat familiar because in that bank problem in section 1, that's actually what we were doing. We made an interval for the proportion of customers that called in that got to a representative under 30 seconds. Okay, but it was a proportion. Okay. The formula you see here is what we call our standard error. Okay. Okay, so think about it like this. To construct this interval, we're going to use a normal approximation. For the normal approximation that we use, this would be our standard deviation. Okay? When you're calculating margin of error, it's like half of it. Okay? You also have to factor in the critical value, which you can see up above there. The statistic would be p hat. You'll actually see on the next slide, the critical value is technically a z-score. Okay? And then this standard error, that's what goes there. And those three pieces together we use to construct our interval. Okay, so in class I'll play around with this a little bit. You can find a critical value really for any confidence level you want. We talked about that in section 1, how it's your confidence level that determines your critical value. Okay, so look at this. They're drawing the cutoffs right there. Okay, so 95% of all possible samples would be in there. That would be the interval. And then you'd have 5% that would not, 0.025 and 0.025. If you wanted to go verify this number, you could go do inverse norm, and then for your left area you could say 0.975. You would use that and that. Okay, I'll show you how to do that in class to get some of the others. Actually, what we'll do really is verify the three that you should know. Because you got that one, 1.96 for 95. 90% is another one that you should just memorize. There's actually a little way in your packet to look it up, which I'll show you sometime in section 3. 90 is 1.645. No surprise there. Lower confidence level, that'll give us a more narrow interval. It's not going to be as wide. So notice it went down from 1.96. If you want to go up to 99, you got to use 2.576. Okay? Those three you should just know, right? Because typically our confidence level is going to be one of those three. All right. So we already kind of took a look at this. There you see the statistic is p hat, critical value is z, and there's the standard deviation of your statistic, which we'll also call our standard error. Okay, for a proportion, this is how the interval is put together. Let me add to this, because I'm going to show you the 4-step here in a minute. Use this for every problem. What I'm getting at here, don't do it for every single problem if you're constructing an interval. Okay, even if you're not told to use it, but it says construct and interpret a 90% confidence interval, then you should do it, even if it doesn't say so. Okay? So in the state, we're basically defining our parameter and quoting our confidence level. Okay? That'll basically be a sentence. The plan step we've talked about before. We have two conditions to verify. The do step is where the interval is constructed, right? It's just number crunching. And then the conclude, I gave you the script for what to say a couple of days ago in section 1. That always really looks the same. With the exception, right, that in context, like always. All right. Wonderful context here. I love to mix it up a little bit and get some fun examples. You can read through the context there in the black. Estimating the proportion of couples that tilt their head to the right when they kiss. That's right. That's the one I'm going with this morning. I'm recording this in the morning. It may not be morning where you are or when you're watching this. Regardless, that's the one I'm going with. Okay? So a couple things that I really need from this, and honestly, it's not a ton. I need that, and that. Got everything I need. Sample size of 124. 66.9%, that's p-hat. That's my statistic. Right? We took a sample of 124 couples and found that 66.9% tilted their head to the right. Well, there you go. Okay, and we're going to use 95% as our confidence level. There's the state, right? We want to construct a 95% confidence interval for the true proportion of couples who tilt their heads to the right when kissing. Okay, I defined my parameter, and I quoted my confidence level. That's all I have to have. Okay. Now, right at the beginning, of the plan, like right before I do my conditions, I'm going to name the interval that I'm doing, okay? For a couple of reasons. One, you have to, okay? At this point, we have to name, you'll see by the time we're all said and done, we have like by the end of the year, we have like 12 or 13 tests that we do. Each chapter it grows a little bit, so we just specified exactly what procedure we're going to use. We're doing a 1 proportion z interval. If you want to use the calculator to help out with the do step, you certainly can, but the second reason that I want you to write that is that matches the exact name of the test that you're going to choose, right? Which I like, that it should help you navigate through the calculator. Rest of the plan step is my conditions. For random, we have an SRS of n equals 124 couples. All right, normal condition, our second one. And again, like what is going on with the normal condition is the critical value that I'm going to use of 1.96 comes from a normal curve, right? So, yeah, I mean, I need to verify that I can use a normal curve before I go do that, okay? Just two things I got to verify here. One, 83 is greater than or equal to 10. Those are the couples who did tilt their head to the right. There was 41 that didn't. Those are both at least 10. We're good to go. Okay? We're good to go. Okay? Do step. Start with my statistic, add and subtract critical value times your standard error, which would be 0.669 times 1 minus 0.669 over 124. Okay? At this point, there's no expectation to show the number crunching of the interval. Okay, we've kind of done what we need to do. That we've got all three parts, right? It's kind of consistent with how we do things. Like, we want to show supporting work, and we always do, but we don't have to show every step along the way. Okay? All I want with this is my interval, which would be 0.586 to 0.752. Okay? And you might be wondering if the calculator could help us out. It can, right? And I will put together a tutorial on the TI-84 and put it on Schoology, and I'll show you in class. Not only could you obviously use your calculator to number crunch this, there's a program that will basically do it for you, to the point all you have to tell it is, I think 83, you have to tell it 83 and 124 and then 95% confidence. You just have to type in those three things and it will get the interval, and you should use it to make sure that the number crunching is done correctly. And there's our conclusion. We're 95% confident that that interval, 0.586 to 0.752, captures the true proportion of couples who tilt their head to the right when kissing. 95% confident, it's somewhere between 58 and 75%. Alright, so that was a look at a four-step. I'm going to show you one other kind of problem you could expect to see, and it's if you want to choose your sample size off of a margin of error. Okay, it involves a little solving, but it's kind of an interesting little problem. So notice you have that's your margin of error, right? The critical value times the standard error. We call that margin of error. And basically, we can set up an inequality and just choose the margin of error that we want. Okay. This is important. If you don't have a value for p hat, just use 0.5. Okay, you're going to get the safest and the biggest possible sample size, and then you'll know no matter what p hat is, you're going to get a sample size that's still going to get you within that margin of error. So let's do a 95% confidence level, and we want to get within 3%. So this is what it would look like. .96 times the square root of 0.5 times 0.5 over n, and we want that less than or equal to 0.03. Okay? We have ourselves an inequality that can be solved, and specifically it can be solved for n. Okay? It can be solved for n. Similar to the confidence interval, this is really, for the most part, what we're looking for with supporting work. Okay? Meaning this, like if you were solving for a margin of error, this has got to be on your paper, right, that you set this up. As far as what steps you show to solve, we're not very picky. Okay? We're not. You can kind of solve it really any way that you want. Just so you know how to do it, I'll show you all the steps that I would use. Right off the bat, I would divide both sides by 1.96, as well as simplifying the top. I would then square both sides. This right side is eventually just going to go into my calculator, so I'm not too concerned that it's getting a little messy. multiply both sides by n, and we would get 0.25 less than or equal to that big mess, 0.03 over 1.96 squared times n, and then finish it off by dividing by that big mess. Again, it's not required on a test that you would have to show every single one of these steps. You can kind of use your calculator. You know, sometimes it's helpful to write down steps as you go, as you plug stuff into the calculator, but that's kind of up to you. The equation at the beginning, or the inequality at the beginning, has to be written out. So what's on the left side there, I would throw into a calculator, and I would get that, 1067.11. This is where the inequality thing comes in, if we get a decimal. If we round down, we're not going to make it inside our margin of error of 0.03. If we round up, we're guaranteed that we will. So for my final answer, I would always round up and say 1068. If I want, at the 95% confidence level, if I want to be within 3% margin of error, a sample size of 1068 will always do the trick.